Now we're going to look at a triangle that's on a coordinate axis and see if it's congruent, if any of these points are congruent to the current triangle that's shown there, PQR. The key thing here is we need to know what the lengths of the three sides are. So in this case, you notice that PQ, pretty easy to just count that out and go 1, 2, 3, 4. So PQ is 4. Going down, we've got 3 there, so QR is 3. And then to find this distance right here, we know that this point is 1, 2, 3, 4, 5. So it's 5, 4. Whoops, negative 5, 4. Thank you. And the other point is at negative 1, 1. So if I want to find PR, I'm going to do the square root of negative 5 minus a negative 1 squared plus 4 minus 1 squared. This gives me the square root of a negative 4 squared plus 3 squared. And you notice it's the same numbers that are here, and that's always going to be true. So we get 16 plus 9. I'm going to have to scooch this down. We get square root of 25, which gives us 5. So therefore, the triangle that we have here has lengths of 4 here, 3 here, and 5 here. So we'll want to see if that's true for the other points. So I'm going to just start with A, and hopefully this is the right one, because otherwise it is a lot of work. With this first one, you notice the negative ones are the same, so the distance is going to be found by looking at these two numbers, and the distance from 1 to 5 would be 4. So let's call this A, B, and C. That would make AB equal to 4, because again, it would be the absolute value of these two subtracted from each other. So 1 minus 5, which is the absolute value of, absolute value of negative 4, which is 4. Looking at these two, you notice they both have 5 in them, so we can simply look for BC at the absolute value of those two. We've got a negative 1 minus a negative 4, and this gives me negative 1 plus 4, well, negative 1 plus 4, which ends up being the absolute value of 3, which is 3. It looks good so far. And let's see, the third one would be AC, and we're going to have to use the distance formula there. But as I told you, once we know these two, if it's a right triangle, the third one should match up. So let's just try it. We have negative 1, minus a negative 4 squared plus 1 minus 5 squared. And this should be rounded. So there we have plus a positive gives me 3 squared, and that's plus a negative 4 squared. And from here, hopefully you can see that we're going to get the same answer in both cases. It would be 9 plus 16. That's square root of 25, which is 5. If we go back then, we can say since these have lengths AB, BC, and AC are 3, 4, and 5, that the answer here would be A. Okay? So again, we know PQ and QR are 4 and 3. The distance for PR ends up being 5. And then they tested it as well. We need another triangle with lengths of 3, 4, and 5. So the distance from here is 4. Here it's 3. And from negative 1, 1 to negative 4, 5 would be 5. So our answer is A. Okay. So it says to graph these two and show that they're congruent, you need to use the distance formula. I'm just going to go through this pretty quick. In the graph, if you look, there's a length of 2 here, so that would be 2 and 3, so the distance from here to here is 3. Going down, this is 2, 4, 6, so the length there is 6. Similarly, this is 6 and this is 3. And in both cases, if we did LK or TS, it would end up being, in both cases, because of what I told you before about these numbers, it would end up being the square root of 3 squared plus 6 squared, which is the square root of 9, plus 36, which is the square root of 45. And if we simplify that in both cases, we'd get 3 rad 5. Okay? And that's it. Thanks.